right, technical difficulty. I'm having so many difficulties right now. My USB flash drive can't hold all these movies. So take it back one step. So we left off at example number 5, solving exponential equations. We have 2 to the x plus 1 power equals 5 to the 1 minus 2x power. I want to remind you that if you have two numbers, if m equals n, you have two numbers that equal each other, then if you take the log of both of those numbers, they equal each other also. It's kind of like if you multiply one side by something and you multiply the other side by the exact same number, it still balances the equation. So taking a log, it's kind of like doing an operation on both sides. So that's what I'm going to do here. Because 2 and 5 are not the same base, I can't use all of my fancy properties. So what I'm going to do is I'm going to take the log of both sides. You could either take log base 10, or just log, or you could actually use the natural log, but I know sometimes that seems scary to you, the natural log. So I'm going to start with just log base 10, and I'm going to do the log of 2 to the x plus 1 power equals the log base 10 of 5 to the 1 minus 2x power. Now that I've taken the log of both sides, I can use some of my properties, because I now do indeed have the same base. These exponents can be moved to the front, so I really have x plus 1 times the log base 10 of 2 equals 1 minus 2x times log of 5. All right? And then here's something crazy that we're going to do. You ready? This is a little bit weird. We're going to actually distribute the log to each of these things, to each of these pieces. So I'm going to distribute the log. I'm going to have x times log 2 plus 1 times log 2, which is just log 2, and then 1 times log 5, so I have 1 times log 5, minus 2x times log 5. My goal is to get x by itself here. That's the goal, so keep that in mind. Now that I have, do you notice I have x's on both sides, and I have plain numbers? Log base 10 of 2 is a number. Okay, that's an exponent, it's some type of number. So what I'm going to do is I'm going to put all my x's to one side and all of my plain numbers to the other. So I'm going to add 2x log 5 to both sides, and then I'm going to move this guy over. So I end up with x log of 2 plus 2x log of 5. Okay, I don't know if you can see that. Let me move this up a little so you can see it a little bit better. Equals log 5 minus log 2. It's minus log 2 because I have to subtract this guy over to the other side. Now I'm going to factor out my x's. So I'm going to factor out this x, because I only can factor out a 1x I mean. So I have log base 2 plus 2 log 5, and that equals this log 5 minus log 2. They do have, all right, and then let's get x by itself. So I'm going to divide by log 2 plus 2 log 5 and do that to both sides. And this is actually what I can punch into my calculator. This cancels off. And I'm going to actually punch that into the calculator. I'm going to hit the log base, just log 5 minus log 2, and then I'm going to hit divided by log 2 plus 2 times log 5. And you will find that that's approximately 0.234. I recommend try this. Once you have this in your notes, try this in your calculator and actually see how that punches in and you get the same answer as I do. And then the last example is example number 6. By the way, if you find this going way too fast for you, I'm putting this on YouTube so you can go home and watch it again when you go to do your homework. So this is e to the x plus 3 power equals pi to the x power. Do you notice they don't have the same base? I have an e and a pi. So what I'm going to do is I'm going to choose to rate, instead of doing log, raising each to the log on both sides, or at least making it log e and log pi, I'm going to do the natural log. The reason I'm choosing natural log is I see that I have an e here, so that just tells me, you know what, I should probably do something with the natural log. So I have natural log of e to the x plus 3 power equals the natural log of pi to the x power. We're going to do what we just did in example 5. I'm going to go ahead and bring this forward, bring my exponents in the front. So I have x plus 3 times the natural log of e equals x times the natural log of pi. Now right there you should start thinking the natural log of e. The natural log of e is saying log base e of e. So e to the what power gives you e? This is 1. This whole thing equals 1. So I'm going to write that. This is really 1 in disguise. So all I have left is x plus 3 equals x times the natural log of pi. The natural log of pi is a number. Keep in mind that's a number. I'm then going to, I'm going to subtract 3 over this way. And I'm going to subtract this x natural log of pi over the other way. So I'm going to have x minus x natural log of pi equals -3. I'm going to factor out an x because I'm trying to get x by itself. And then I'm going to divide both sides. Let me move this up a little. Divide both sides by 1 minus the natural log of pi. And this I punch into my calculator. I'm going to say x is approximately, I'm going to punch that into my calculator, and it comes out as actually a really surprising big number, 20.728. Okay. The substitute has your homework on this lesson, and again, you'll find this on my channel, which I will give to the sub and write it on the board. Good luck, guys.